Good afternoon, everyone. So this is an educative session hosted by Legacy by Gabriel. Here on this session, we're going to be treating MTS 101, that is Introduction to Mathematics. So on this session now, we're going to be treating a topic called Binomial Theorem now. So Binomial Theorem. Now, what are we going to be treating on the Binomial Theorem now? We're going to be treating things that have to do with expansion, coefficients, and the likes now. So firstly, let's consider this. If we have an expansion a plus b raised to the power of 2, right? So normally we know we want to expand it. It's going to be on two sides now. So we will multiply a square plus ab plus b square. That will be equivalent to a square plus 2ab plus b square, right? Easy, right? So let's consider another one. We have a plus b raised to the power of 3 now. So at the expansion, we know it's going to give us a cube plus 3a square b plus 3ab square plus b cube. But if we now have an expansion with a very big power now, for example, a plus b raised to the power of 10, it will actually be unconventional for us to write a plus b in 10 places. That's going to waste a lot of time. So what we are going to do is, that's why we are going to employ what we call binomial theorem now. Binomial theorem now. So let's talk about one of the foundations of binomial theorem, something called Pascal's triangle. So Pascal's triangle, from the name, was actually invented by a man, Blaise Pascal. Blaise Pascal was a French mathematician. So what does the triangle entail now? So for example, now we have 1 now, then 1 plus 1 2, and then 1. We have 1 3 and 1. And now we'll all be wondering, what is the purpose of this thing? What is the importance of this thing? Let's draft it out first before we talk about the importance of this now. So we have 1 4 6 4 and 1. Nice. 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3, and 2 raised to the power of 4. That means the addition of this will give you 2 raised to the power of 3. So now, what is the essence of Pascal's triangle? Now, for expansions now, for example, expansions for something like this now, we are not going to have a plus b in 10 places because that is going to waste a lot of time now. So from this now, if we have a plus b raised to the power of 10 now, so if I have the 10th term now, I'll just pick out the coefficients and then I'll add it to something like this now. So for example, if we have a plus b raised to the power of 3 now, yes, and we have something like 2 raised to the power of 3 now. So we have 1a cube, or it's also written as a cube, right? We have 3a squared b. Now look at it now. Look at the pattern in this now. A is reducing, b is increasing, because from this now we have b raised to the power of 0, and we know naturally that a raised to the power of 0 is 1. For 1 here we have b raised to the power of 1. A is reducing, b is actually increasing. So let's move. What's the next one? A is actually going to reduce by another power again, ab squared, right? And the last one, b, we have b squared already, and we have our last coefficient as 1. It's just be 1b cube, or 1 a raised to the power of 0 b cube. So this is practically the essence of Pascal's triangle now. What is practically doing is actually making our work much more efficient and faster now, rather than just, so we have something like 2 raised to the power of 10 now, and we have the expansion and the coefficients now, because these are the ones that are called coefficients now. We don't need to stress ourselves and write a plus b in 10 places again. That will actually waste a lot of time now. So if we have the coefficients now, just add it. Know that one time will increase, one time will decrease as the pattern shows, and then boom, we have our answer. It's practically simple now. Let's go to the general formula of the binomial theorem. General formula of binomial expansion. So in this now, we're going to use something called combinatorics. Now, combinatorics actually involves permutation and combination now. Permutation and combination, I'm sure most of us are familiar with that, or even though we are not now. So we have something like this. We have n combination of r now. So this is going to be n factorial divided by n minus r factorial r factorial, right? So let's impute numbers there. Let's see how it works. So let's say we have n as 5 combination and r as 2. We're going to have this 5 factorial divided by 5 minus 2 factorial 2 factorial, right? And when we have this now, what does factorial mean now? So we have 5 factorial, we have n factorial now, we're having n multiplied by n minus 1 multiplied by n minus 2 and keep going like that. So let's do 5 factorial. 5 times 4 times 3 times 2 times 1. It's not going to extend into the negative part of the numbers. So we're going to stop at 1. Divided by 5 minus 2, that is 3 factorial, and 2 factorial now. Now we know that this 3 times 2 times 1, I'm not sure if you can all see it, 3 times 2 times 1 is most definitely equivalent to 3 factorial. It's most definitely equivalent to 3 factorial. So I can just cancel this out. This cancel this. So there we have 20 divided by 2 factorial, right? So that is 20 divided by 2 times 1, practically 2. That is 10. So this is what we get for 5 combination 2 now. That is practically easy now. If you have something like that now, in combinatorics now, we have n combination of r, n of r, and we have, let's say our first term is a n minus r x raised to the power of r. A n minus r x raised to the power of r. So let me write it down. We have n combination r, we have summation of k is equals to 0 to n. Right? This is our lower limit and our upper limit. And a is power n minus r x raised to the power of r. Practically easy. So now let's say we have something like okay, let's look at an example now. Example that I actually used to use a formula like this now. Let's say, for example, finding coefficients now. So they ask to find the coefficient of, let's say, x squared in 1 plus x raised to the power of 6. We're finding the coefficient of x squared in 1 plus x raised to the power of 6 now. So now I'm going to use, what is our n now? Our n is practically this 6. What is our r now? Our r is going to be, now for this now, we are not looking for just the rth term. Please note, we are looking for the r plus 1 term. R plus 1 term. So let's say our r is practically, we don't know what our r is, right? So we have x squared now. So that will give us r plus 1 is equivalent to 2. This 2. That will now be r is equals to 2 minus 1. R is equivalent to 1. Our r is 1 already. So we always look for the r plus 1 term. So then let's insert our 1 there for r. 1. And what our first term means? Our first term is most definitely 1. 1. A. N minus r. 6 minus 1, right? 6 minus 1 and x raised to the power of r. What is r? 1. Easy peasy. So that means we have, excuse me please, you have 6 factorial, because this is actually combinatorics, it's combination, divided by 6 minus 1 factorial, 1 factorial, multiplied, I'm multiplying everything here, by 1 raised to the power of 5 times x again. That will give us, this is 6 factorial, this is 5 factorial, 1 factorial. I can practically do 6 times 5 factorial. Yeah. Yes, it's actually going to be correct. So 5 factorial is actually going to carry 5 factorial here, leaving us with 6 divided by 1, practically 6. We have 6 multiplied by 1 raised to the power of 5, 1 in 5 places. Easy, that is just 1. Still 1 times x. That is 6x. Now, the coefficient of x squared is 6. Note, coefficient is going to be 6. The coefficient is going to be 6. Practically easy. So now let's move to something like actions now for under indices now. So let's say binomial formula for order indexes. So now let's say we have 1 plus x raised to the power of, let's say, n. Let's use power of n now. So the expansion is going to be 1 plus nx plus n minus 1 divided by 2 factorial plus n minus 1 n minus 2 divided by 3 factorial plus, let's say, n minus 1 n minus 2 n minus 3 divided by 4 factorial and so on. So that's how it works. We get to n minus n and the likes of that now. So let's imagine we have an expression, this 1 plus 3x raised to the power of 1 over 3. 1 plus 3x raised to the power of 1 over 3, and we were asked to find, let's say, the second term now. We were asked to find the second term now. So without budging or stressing myself now, I can just do this. According to the formula now, 1 plus nx, as 1 over 3 is multiplying this, right? 1 over 3 multiplying 3x plus n minus 1. What is our n? 1 over 3. 1 over 3, 1 over 3 subtracted by 1 divided by 2 factorial. And we have to find the second term. So this is practically okay. This is where our expansion is going to stop at, because we are looking for the second term. Yes, the second term. So let's add 1. So you are looking for something like the third term now. Extend to this. Fourth term, extend to this, and the likes of that. So that is 1 plus 1 over 3 times 3x. That is practically 3x over 3, if I'm not wrong. That is just x plus 1 over 3 minus 1 divided by 2 factorial. So 1 over 3 minus 1, let's solve that. 1 over 3 minus 1 over 1. Where our LCM is going to be 3. 3 and 3, 1 times 1, 1 minus 1 and 3 with 3, 3 times 1, 3. That is negative 2 over 3. This is going to be negative 2 over 3. Let's add up. We have 1 plus x plus 1 over 3 times minus 2 over 3. That is minus 2 over 6. Minus 2 over 6 divided by 2 factorial. That is still 2. So that is minus 2 over 9, sorry. Minus 2 over 9 divided by 2 factorial, that is still practically 2. So that will be 1 plus x plus minus 2 over 9 divided by 2. So that will be minus 2 over 9 times 1 over 2. That will be minus 2 divided by 18 plus minus 2 divided by 18. So let's add up. That will be 1 plus x minus 2 over 18. Right? So we can just add x plus 1 minus 2 over 18. Where else will be 18? So 1 in 18 is 18 minus 18, 1 times 2, 2. Nice. X plus 16 divided by 18. That's x plus 26. That is 8, 28, 9. That is x plus 8 over 9. If you want to simplify more than this, you can actually do that. So this is us finding the second term in the expansion of 1 plus 3x raised to the power of 1 over 3. Find the expansion 1 plus 3x raised to the power of 1 over 3. So let's look at a question from the manual. Let's look at something like this. They said use the binomial theorem to simplify 3 plus 2x raised to the power of 4. Number 2, tutorial section under binomial theorem. Use the binomial theorem to simplify 3 plus 2x raised to the power of 4. So we have this. So we have 3 plus 2x raised to the power of 4. 3 plus 2 raised to the power of 4. We can actually use Pascal's triangle now. So we can just, anytime we are having something like probably an assessment or test or exam or the likes, you can just put your Pascal's triangle beside you, and from there just infer the values now. Or we can also take another approach now. We can just use combinatorics now to just do it. So we have something like 4 combination of 0, 3 plus 3 raised to the power of 4, this note, 3 raised to the power of 4, 4 combination 1, 3 raised to the power of 3, 3 will most definitely decrease, and then 2x will most definitely increase, plus 4 combination 2, 3 raised to power of 2, decreasing, descending, ascending, and this is 2x raised to power of 2 plus 4 combination 3 raised to power of 1 and 2x cubed plus 4 combination 4 3 raised to power of 0, literally 1, and 2x raised to power of 4. Okay, let's do this. 4 combination 0 now, so let's simplify it, let's break everything down. So that is 4 factorial divided by 4 minus 0 factorial 0 factorial, and this is 3 raised to the power of 4, that should be 81 plus 4 combination 1, that is 4 factorial divided by 4 minus 1 factorial, and 3 raised to the power of 3 is most definitely 27, so this is 27, sorry, multiplying 2x, and we have 4 combination 2, that is 4 factorial divided by 4 minus 2 factorial, and multiplying, this is 9 and this is 4x squared, and this we have 4 factorial divided by 4 minus 3 factorial, and 3 factorial, this is most definitely 3, and this is 8x cubed. And the last one is 4 factorial divided by 4 minus 4 factorial and 4 factorial. This is 3 raised to the power of 0, that is 1, and 16x raised to the power of 4. So now let's continue it here. Right, we have 4 factorial, that is 4 times 3 times 2 times 1, that is 24. 4 times 3, 12, 12 times 2, 24. 4 minus 0 factorial is still 4 factorial, and then 0 factorial. So everything here will give us 1 now. So we proceed. We have 81 plus 4 factorial. This will be 4 times 3 factorial, and this is 3 factorial. 3 factorial is going to cancel out 3 factorial, so we have 4 divided by 1. That is 4, multiplying 27 and 2x. You can actually verify all these answers. And 4 factorial, 4 minus 2 factorial, that is 2 factorial. 4 times 3 times 2 factorial, 2 factorial is cancelled out 2 factorial. So we have 4 times 3 divided by 2 factorial, that is 12 divided by 2, and we have 6. Multiplying 9 and 4x squared plus, we have this 4 factorial and this is 1 factorial. 4 times factorial divided by 4 minus 3 factorial, 3 factorial, that is 4 times 3 factorial. That 3 factorial is cancelled out with 3 factorial. 4 divided by just 1 factorial, that is 4. 3 and 8x cubed plus, this is 4 factorial divided by 4 minus 4 factorial, yeah, 0 factorial, 4 factorial times 4 factorial. We're going to have practically 1 here. That will be 16x. So this is practically our expansion now, and we have to simplify it now. So let's break it down. That is 81 plus, we're going to have 27, 4 27 2. 27 times 2 is 54. We have 54 times 4, that is out 54 multiplying 4, that is 16, 1, that's 216. 216x, please let's not ignore that x, plus 9 times 4 is 36, 36 multiplying 6, we are going to have 6, 3, we have 6, 18 and 21, so 216x squared plus 24, 24 multiplying 4, 96, 96x cubed plus 16x is power of 4. So this is practically the simplification now. For here, you know we have x to the power of 0, x to the power of 1, x to the power of 2, x to the power of 3, and x to the power of 4. That's practically it now. So before that now, I actually noticed that I actually forgot to give you the proper definition of what a binomial is now. So a binomial now is an expression containing two terms like bi, two, and nomial term. So any expression that actually contains two terms is what we refer to as a binomial. And those terms are actually separated by an operation. It can be plus, it can be minus, it can be subtraction, it can be multiplication. That's what a binomial is now. So let's take another question here now. So I actually love this question. I asked to number 3 in the tutorial section now, number 3. And we're asked to expand 1 plus 2x raised to the power of 5. So we have 1 plus 2x raised to the power of 5. And the question is not over. After simplifying and expanding it, we are going to obtain an estimate of 1.02 raised to the power of 5. So let's do that. So we're going to have 1 plus 2x raised to the power of 5 now. So let's just use our Pascal's triangle now. So we have 1, 1, 1. 1, 2, and 1, just not to waste any time. 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is what we are using, it's the fifth time. Okay, no, that's 1, 5, 10, 10, 5, and 1. So this is what we are using. So 1 plus 2 is raised to the power of 5. The first one is 1. We just have 1 raised to the power of 5. What is the second coefficient? 5. So we have 5 into brackets 1 raised to the power of 4, most definitely going to decrease, and 2x raised to the power of increasing. It just started increasing 1, right? Easy. And then okay, so we now have plus, next time is 10. 10, 1 raised to the power of 3, 1 is decreasing, let's not forget that, and 2x raised to the power of 2. Plus, then again, 1 raised to the power of 2 and 2x raised to the power of 3. 2 is increasing. Plus, don't mind why I structured it. So plus 10, okay, and we have 5 now. 5, 1, 2x raised to the power of 4. And finally we have 1 multiplying 2x raised to the power of 5, or just practically 2x raised to the power of 5. Let's get this. So 1 raised to the power of 5 is most definitely 1. This is 1 times 2x, this is 5 multiplying 2x, that is 10x, plus, this is 1 cubed, this is 2x squared, this is 4x squared. 4x squared times 10, that should be 40x squared. And this is, same one, this is 8x cubed multiplying 10, 80x cubed, plus, this is 16x, for 16 times 5 should be 80x 4 plus 2x raised to the power of 5. It's just 2x raised to the power of 5. No, 2x raised to the power of 5. That should be 32. Nice. 32x raised to the power of 5. Now, this is our expansion now. And we are going to use it to obtain an estimate for 1.02. 1.02 raised to the power of 5. So now 1 plus 0 to raised to the power of 5 now. You have to make this guy look like this guy. That is practically what we are doing. You have to make this guy look like this guy. Now, I think we all agree with me when we say that 1.02 is equivalent to 1 plus 0.02. Do you agree? 1.02 is equivalent to 0.02. So if you add 1 plus 0.02, you're most definitely going to get 1.02, right? So if 1 plus 0.2 is this is our expression, right? So, and this now, we have this and this now. So we have 1 plus 2x raised to the power of 5 now. We can do 2x is equivalent to 0.02. But this is 1, this is 1. 2x equivalent to 0.02. So x is 0.02 divided by 2. That gives us 0.01. So don't just mind where I structured it. So we just equated this and this, and sorry, this and this. 2x is equivalent to this. So then made x subject of formula, and we divided by the coefficient of x, that's 2, and we have 0.01. So we have found x as 0.01, but our work is not finished yet. So after finding x as 0.01, just substitute. We have our expansion here, so just substitute it. 1 plus 10, 0.01 plus 40, 0.01 square plus 80, 0.01 cube plus 80 0.014 plus 32 0.0145. So I would have loved to actually expand this with you, but I'm actually with the calculator now. So you can just try this. At least you know the section already. On the tutorial section under binomial theorem number 3. So just multiply everything and then boom, we have our answers. So this is going to be all under binomial theorem. Thank you for actually staying with us, and please don't forget to subscribe Legacy by Gabriel on YouTube. So this is my number now, my WhatsApp number. This is not clear. So if you have any questions, if you have any issues, if you have anything that you actually need to be broken down, you can actually contact me. This is my WhatsApp number. Please don't forget to subscribe Legacy by Gabriel. So my number 0816-327-0274. Again, 0816-327-0274. Don't forget this was hosted by Legacy by Gabriel. Thank you.